So have you ever really thought about that soda can in your hands? Or the massive skyscraper you see on your way to work? Well, today we're going to dive into the hidden story of the one thing that connects them both, aluminum. I mean, it really does sound like a riddle, right? On one hand, you've got these gigantic structures that practically scrape the clouds. And on the other, something so incredibly light you can crush it with one hand. So, what in the world could possibly link these two things? The secret ingredient here is aluminum. And what's wild is that its story doesn't kick off in some high-tech, futuristic lab. Nope, it all begins deep inside the Earth's crust as a simple, kind of reddish, clay-like rock. Okay, so let's jump into the first part of this journey, from Earth to element. How in the world do we take that humble rock and turn it into a pure, usable metal? So it all starts with mining this ore called bauxite. That's the reddish-brown rock we've been talking about. They crush it up and run it through this whole chemical refining process that basically gets rid of all the other stuff. And what you're left with is this superfine white powder called alumina. You can pretty much think of it as pure, concentrated aluminum, just waiting for the next, even crazier step in its transformation. All right, section 2, the art of alloying. Here's the thing. Pure aluminum, it's actually pretty soft. It's not all that strong by itself. So to really unlock its potential, it needs some superpowers. And that's where the magic of alloying comes in. So what is alloying? Well, think of it like building a dream team for a metal. You've got your star player, which is aluminum, right? Then you start strategically mixing in tiny amounts of other elements. You get a brand new material with a totally different set of skills. So who are the other players on this super team? While we're talking about elements like magnesium, silicon, copper, zinc, even a bit of iron. Each one brings something special to the table. Like, you add just a little bit of copper, and suddenly the alloy gets way stronger. Or you add silicon, and it helps the whole mix flow better when it's melted down. It's kind of like a super precise recipe. Now, it's really important to know this isn't the same as an impurity. An impurity is, well, it's like an uninvited guest at a party. It's an element that just kind of sneaks in by accident and can really mess with the final properties. Alloying, though, that's the complete opposite. It's totally deliberate, it's controlled, and it's all about getting a very specific, awesome result. Okay, section 3, a material's superpowers. We've mixed our perfect alloy. So what did we get? What amazing new abilities did we unlock? Let's check out the new strengths this stuff has now. And wow, you can really see the difference it makes. Just look at this comparison. On one side, you've got pure aluminum, pretty soft, not super useful for a lot of things. But then, look at the alloy. It's so much stronger, and you can tweak its properties for literally thousands of different jobs. The change is just incredible. So first up, strength and hardness. This is probably the most obvious new power. We're talking about a massive boost here. This is exactly what lets it become the structural frame of a skyscraper or the engine block in your car. Parts that have to handle some serious force and wear and tear. But here's the really cool part. Even though it's gotten so much stronger, these alloys can also be amazingly tough and flexible. They can take a huge hit without just shattering into a million pieces. And that is exactly what you need for something like a car's crumple zone or the body of an airplane. Another huge one is durability and corrosion resistance. See, aluminum has this neat trick. It naturally creates this super thin, tough, invisible layer of oxide all over its surface. It's like it builds its own personal force field, and that shield gives it fantastic protection against corrosion. It's the reason it doesn't rust like iron or steel, which makes it perfect for stuff like window frames that are out in the rain all the time. And let's not forget about its original talents. Even after all that alloying, it's still a fantastic conductor of both heat and electricity. That's why it's light enough for those massive high-voltage power lines you see stretching for miles, but it's also the reason your food heats up so nice and evenly in an aluminum pan. All right, our final section, from use to reuse. So we've got this amazing material, right? It's strong, it's light, it's durable, but honestly, the most remarkable part of its story is what happens after we're done using it for the first time. This is where the whole thing comes full circle. I mean, the list of what we use it for is just endless. And this brings us right back to that question from the beginning. It connects skyscrapers and soda cans for sure, but it also connects the airplane you fly in, the smartphone, and even the foil that you wrap your leftovers in. Its versatility is, quite literally, everywhere you look. Okay, now here's maybe the most mind-blowing fact of this entire journey. With all this aluminum being used for, well, everything, you'd think we'd be constantly digging up more and more bauxite, right? But get this. Roughly 75% of all the aluminum that has ever been produced is still in use today. How is that even possible? One simple, incredibly powerful word: recycling. You see, aluminum can be recycled over and over and over again, infinitely, and it never loses its quality. And here's the real kicker. Recycling it uses only about 5% of the energy it takes to make new aluminum from that bauxite rock. That is what makes it one of the most sustainable materials on the planet. Its journey never really ends. It just starts over. So think about that. From a simple reddish rock pulled from the ground to a super material that literally builds our modern world and then circles all the way back to be used again and again. It's a truly remarkable journey. And it really makes you wonder, doesn't it? What's next for this incredible element?